Here's an example where we want to find the volume of a solid shaped like an ice cream cone that's bounded by the functions z equals square root x squared plus y squared and z equals square root 18 minus x squared minus y squared. And this first one's going to be a cone, so z squared is x squared plus y squared. The second one here, this is going to be the upper half of a sphere, because if I square both sides, I have z squared is 18 minus x squared minus y squared, which gives me x squared plus y squared plus z squared is 18, which is the, what? We're going to have the upper half of this sphere. So what does this look like? You can kind of draw this in here. So I have this cone, and it's covered by this top half of this sphere, and I can project downward here and think about this base in the xy plane. So my base here is going to be down there, and you can see how the edge here projects downward onto the xy plane. So I want to find what this base is, and so these two intersect. So for the radius of the base, we have x squared plus y squared is 18 minus x squared plus y squared. And if I want, I could write this as r squared is 18 minus r squared. So 2r squared is 18. So r squared is 9. So r is 3, right? It has to be positive. Now, what I want to do is think about projecting up here from some point down in the space up to the cone, where we hit the solid and we go through the solid to the surface on the sphere here, where we come out. So here, you keep going, but our height here, our h, is going to be the difference in these z values, right? So my little height here, h, is going to be square root of the top z, which was, what, square root of 18 minus x squared minus y squared. So I have a square root of 18 minus r squared minus the cone, z is just r, like so. So that gives me the height there at a given point. And now I want to think about forming the integral. So I look down on the xy plane. Okay, so our xy plane, we had something like this, and we had our circle of radius 3. We had the whole circle. So our volume that we're going to get is going to be the integral 0 to 2 pi d theta, and then 0 to 3 dr. You have this r here that you don't want to forget about. That's from the transformation. And then in here we have square root 18 minus r squared minus r. Okay? And I claim this is very straightforward to work out. The 0 to 2 pi d theta, that's just going to effectively multiply what we get on the inner integral by 2 pi. If I would break up this inner integral into two pieces, so I have 0 to square root of 3 r square root 18 minus r squared dr minus integral 0 to 3 r squared dr. Right? I just took this r here and distributed it, wrote it in front of this one, and the r times the r there made the r squared down here. So on this first one here, on this guy here, I would let u be 18 minus r squared. So du is negative 2r dr. So that means r dr is negative 1/2 du, right? So this integral here is going to give us what? We're going to have integral from when r is 0, u is 18, and when r is 3, u is 9. And then I have square root of u, negative 1/2 du, right? So this is going to give us what? We're going to have negative 1/2, and then 2/3 u to the 3/2 from 18 to 9, right? For that one. This guy over here, though, is just going to be what? It's going to be 1/3 r cubed from 0 to 3, or just, what, 9. So, leave it to you to finish this. So I'm going to have this, what I get here, minus 9, and then going back up here, I put all that inside this, right in there, and that's just going to multiply that result by 2 pi. And so that's that.